When did you become a vegetarian?
Okay, good morning. So let us continue the lesson. So I have written the formulas we might need here. I know that these formulas I haven't actually went through, but let us keep it like this. It's not something, for example, the derivative of tangent, we can express it in this form, which was on the lecture notes before. It's not a very big problem here, but let us see how the time will be. So then I will come back to these things at some point. Okay, so there is one more rule that I want to add to these general formulas, and that's the last one, number 6, and that is called the chain rule. Okay, so so let me motivate you a little bit. For example, if I give you two functions, if I give you function f of x to be sine x, if I ask you, do you know the derivative of this function? The answer is yes. It's on the table, yes? And if I give you another function g of x, for example, x squared, if I ask you, do you know the derivative of this function? Again, the answer is yes, okay? If I ask you now, do you know the derivative of x squared plus sine x? The answer is yes, because that's the sum, so you differentiate this one plus the derivative of this. If I ask you, do you know the derivative of the difference? The answer is still yes. If I ask you, do you know, for example, the derivative of sine x squared times sine x? The answer is again yes. That's a product rule. If I ask you, for example, do you know the derivative of sine x over x squared? The answer is again yes, because that's a quotient rule, yes? But if I ask you at this point, do you know the derivative of sine x squared? None of these formulas are suitable for this. I mean, if you see this function is not a very strange function. It composes of two parts. One part is the sine function. One part is a squaring function. But this function is not a sum, is not a difference, is not a product, is not a quotient. It's called the composition of these two functions, one after the other. So for example, if I want you to ask what is the meaning of this function, it means that when I take x and put it here, x squared will act on that function first, on that number first. For example, if I choose x to be 2, x squared becomes 4, and then after 4 is found, sine will apply on 4. So it means that a squaring function acts first, and when you get the result, sine function comes and acts later. Okay, so this is, we say sine after squaring. So this is a composition of two functions. So if I want to address how can I write this mathematically, I can say that, okay, first I send x to this machine, which is called g. This will give me x squared. And then I take this squared and send it to machine f. Machine f is just taking sine. I am sending x squared to f. It gives me sine x squared. So I hope that this operation that you see on the board now is not one of these arithmetical ones. Yes, it is a composition of two functions, one after the other one. Which one acts first? G acts first, and then f comes after g. So this notation we use in mathematics for that is we write FOG and we read it F after G. So when I say FOG acts on X, it exactly means that. It means G acts first on X. Whatever Gx is will play the role of input of the next coming function F. Okay? So this is a composition of two functions. For example, here, if I give you f of x is this and if g of x is that, if I ask you what is f of g of x, how do you do it? I want you to understand f after g. So g should act first. It means should act first. So it means that I copy and paste f. F is still waiting. G acts on x. G acts on x gives you x squared. Now f is supposed to act on x squared. What is f function? f function takes sine from the input, but the input is x squared. So f will take sine of the input. Yes? Is that clear? So this means that if this function is given to you, you need to understand yourself that this function is a composition of these functions. This operation is called composition. F after g. Okay? So the chain rule is a rule that tells you that if you know the derivatives of these functions, how to find the derivative of the composition of two functions, of those functions. Is that understandable? Yes or no?
Yes.
So if I ask you what is the content of the chain rule, the chain rule tells you that if you have a function that can be imagined as the composition of two or more functions, composition means this, then, and if you know the derivative of each part, the chain rule will allow you to find the derivative of the new function. So that is the functionality of the chain rule. Is that understandable? Okay, so for example, if I want to motivate you a little bit more, so if I give you this function, if you don't mind, let me call it h now. H of x is equal to x squared plus 1 to power 2. Okay? If I ask you, can you calculate the derivative of this function? Even if you don't know anything about the chain rule, you know what the chain rule is going to do, but still I haven't presented the chain rule. So we say that we pretend that we don't know the chain rule, even though you have studied that in high school. Okay, but here, if I give you this function and I ask you to differentiate this function, how do you do? Expand the bracket, okay? So what do you do? So it becomes x to the power of 4, 2x squared plus 1. And then, of course, it is extremely simple to differentiate it, which becomes 4x to the power of 3, 4x and nothing. And that's your derivative. Okay, but the point is that if I just change my opinion and ask you about this function, and I ask you to differentiate this function, in principle, nothing has changed, in principle, but practically it is a very different thing. Because if I want to expand, I have to raise it to power 200 by multiplying it 200 times, okay? And of course, even though in principle it is doable, but it is not practically possible. So either we have to give up, or we have to find another function. But my question for you is this. Can you also, based on what I described here for you, can you see that this is a composition of two simpler functions? Is it a composition of two functions that I can immediately calculate their derivatives? So how can I understand that? What is the first function acting? You see, this is the function which acts first. If I give an x, this will be done first. And if the answer is found, then I raise it to power 200. So there are two functions involved. Can you see one after the other? Can you tell me what is the first function? By the way, the first function is called the inner function. The second function is called the outer function. So what is the inner function here? The inner function, in my notation, I reserve g for the inner function always. So can you tell me what is the inner function? X squared plus 1. Yes? Can you tell me what is the outer function? X to power 200. Okay? I want to give you a little bit time. Can you feel that what I have written is correct? So you see, if I give you x, this will act. I get a result. Whatever that result is, I raise it to power 200. So there are two functions involved in this function. F after g gives me this function. So I hope that you see that this h, do you agree with what I am writing now? That this h is f after g. Is that right? Okay, now the good news is that, can you calculate the derivative of this? Very easily. Can you also calculate the derivative of this? Again, very simple. The chain rule tells you that if you can calculate the derivative of these individual parts, you are done. You can calculate the derivative of the composition. Okay? And the formula that you see here, let me just give you this formula here. So I want to write it here for you on the board, then I explain the remark up there, down there. It's very important. So the chain rule, the formula for the chain rule is that if you have f after g and you want to differentiate it, what you do, you differentiate the inner function okay, and multiply it by the derivative of outer function, but there is some important thing that you have to be careful. The derivative of the outer function is not calculated at x, it is calculated at the inner function. Okay, so this is the chain rule formula. Okay, so let me apply it for here. Then I will tell you how to do it fast. I want you to understand the concept, and then I will, of course, never I do it like this, I will do it faster, and I will teach you how to do it faster, okay? But let us do this using this idea, okay? So this is very simple. Can you calculate g prime of x for me? Yes. G prime of x is what? Is 2x. Okay? This one, if I want to calculate f prime of g of x, what is the meaning of this? For example, let us go back to the previous lesson. If I give you, I don't know, f of x equals to cosine x, whatever, I mean, let me make it simple. Square root of x. And I ask you f prime of 4. Can you tell me what do you do first? Do you put 4 first and then differentiate, or you differentiate first and then put 4? Yeah, of course, you differentiate and then put 4. So that's the same thing here. F prime at g of x, it means you have to differentiate f first and then replace x with g of x. So that's the meaning of this symbol. Okay? So, okay, let us do that. If I ask you what is f prime of x, what do you say? F prime of x is 200, x to power 199. Okay? But this is not f prime of x. This is f prime at g of x. What is the meaning of this symbol? It means that when you want to calculate this, first you differentiate and replace x with g of x. But g of x is this guy. So I differentiate first and then I replace x with that guy. Yes? And finally, what is the answer? So therefore, what is the derivative of h up there? So the derivative is the product of these two. This one multiplied by that one. So this becomes 200 x squared plus 1 to the power of 199 multiplied by 2x. Yes? Yes? And then of course you multiply it, it becomes 400x x squared plus 1 to the power of 119. That's the correct one. Is that clear? So that's the content of the chain rule. Okay, for example, can you help me to do this one more? I want to calculate sine square root of x. I give you this, and I ask you what is h prime of x. Okay, so how should I do this? I hope that you see that it's a composition of two functions. Yes? So you need to see that on that table there, what formulas you know. You know that you know the derivative of sine x. You know that you know the derivative of square root of x. But sine square root of x acts first. So squaring function acts first. Then after that, sine acts on the result. So this means that sine function is after a squaring function. So that's a composition function. Is that right? So how do you calculate it? So one more time. So can you tell me what is the inner function in this problem? What's the inner function? Square root of x. And can you tell me what is the outer function here? Sine of x. Yes? Do you agree that if I take this and I take that, h is f after g? Do you agree with that or not? Yes. So it means that everyone agrees that h is f o g here, f after g. Okay? So if you are okay with that, then the task is very simple. So what you are supposed to do, you are supposed to calculate the derivative of the inner function, which you see it on the top row on that table, and I told you please memorize it. It's a good formula to know. Okay? And then the only problem is to be careful here. For calculating this, as usual, you first calculate f prime of x. Okay, if you haven't memorized that yet, tell me from the table. The derivative of sine is cosine. But this one has one more step to it. Because I don't want f prime of x, I want f prime of g of x. So this means that first I differentiate and I find f prime of x. Then what should I do? I have to calculate f prime of g of x. It means go and replace every x in f prime with g of x. But what is my g of x? My g of x is this guy. So I would write cosine, but I replace this x with the square root of x. Yes? And then what happens? The answer to the problem is the product of these last lines. Yes? So it means that the h prime x that I want to do is what? Is the product of these two. The product of these two last lines. So this becomes cosine square root of x multiplied by 1 over 2 square root of x, which I prefer to write it a little bit more compactly in this form. So that's the essence of the chain rule. Is that understandable? Okay. I will come back probably at some point and give you some... So here I want to first do these exercises with one another. So let me choose some of the a little bit harder ones. Okay. But before doing that, I want to tell you how to do it faster. So here, this means f of g of x can be written as f of g of x, as I told you. So if I want to write this in another form, this means that f of g of x, whatever it is, I want to take the derivative of that. According to the chain rule, it becomes the derivative of the outer function calculated at the inner function multiplied by the derivative of the inner function. To make it simple to remember, let me give the name u to the inner function. So I want to introduce u as the inner function, and I want to put it here. So instead of g of x, I put u. So this becomes f of u prime. Yes? It becomes equal to f prime of u multiplied by u prime. Okay? It's a very handy tool. I always use this version to do it fast. What does it mean? It means that if f is acting on not x, on a function of x, and you want to differentiate it, you just do it as usual, pretending u is x. If u is x, the derivative is this answer, okay? But now that u is not x, the only thing that you have to remember is to multiply by u prime. Yes? So in principle, if I ask you what is the derivative of this one, you write simply f prime of x. But now, if this is not x, this is a function of x, and you want to do that, momentarily you can pretend u is x and do the same thing. But the only thing you have to remember is that the problem is not finished, you have to multiply by u prime. Is that clear? So that way is easier to do. For example, if I want to do the first example in the notes, as you see here, so number 1, y is equal to 2x to the power of 3 minus 5x squared, and then plus 4, and then to power 10. So if I want to do it, I would never write it like this, because I want you to understand that this is the same formula. But the way that I do it, I will try to find some u here. So for example, I will take this u. Then what do I have? I will have u10. Okay? If you pretend u is x, can you differentiate this or not? What is the derivative of this if you pretend u is x?
Yes.
Is what? Is 10 u to power 9. But because u is not x, there is one thing that you have to be careful. You have to multiply by u prime. Okay? So remember this fact. Okay, so in my head, I took this to be u, and then I will have u to power 10. If u is x, can I calculate the derivative? Yes, the derivative would be this one. But because u is not x, u is a function of x, the chain rule tells me you put an extra factor of u prime there. Okay? So now can you tell me what is the answer? The answer is 10 u to power 9. So it becomes 10. This is my u to power 9 multiplied by u prime. I mean, in the exam, try to do some parts in your head, and it's good to write it down. So by writing down, people understand that you know the chain rule. So this is the chain rule. Do you understand it or not? But you have to continue until there is no prime left. And you will see why it is called the chain rule. Okay? So y prime becomes 10. I copy and paste these parts without even thinking, because you also have to do something fast, and then differentiate this one. So this is a very simple exercise to do. So it becomes 6x squared minus 10x. That's it. And that is the derivative of this function faster, because you also need to do things faster. Okay, for example, let me do the other one. Can you feel it is a chain rule? Can you tell me what is the inner function? Which function acts first? X squared plus 2x acts first, gives you a number, then you take a square root of that number. So a square root function comes after that function. So it's one function after the other. Whenever this happens, you are facing the chain rule. Is that right? Okay, but then you need to take something u. Which one do you think you take u is a good thing? Yeah, this one. Why this is a good choice? Because if I take this u in my head, I produce what? I produce a square root of u. Is a square root of u pretending u is x in my table? Have it in my memory? Yes. What's the answer to this pretending u is x? Is 1 over, can you see the formula up there here? I am pretending u is x. So it becomes 1 over 2 square root of u. But because this u is really not x, that was my pretension, it means it is, I have to multiply by u prime. So that's it. Okay? And then this is a scratch paper, you really don't need to write it down. So y prime becomes, help me, 1 over 2 square root of u. This is my u, but multiplied by u prime. Yes? But is it finished? No, because there is a prime left. So I have to continue until no primes are left. So it becomes 1 over 2 square root of x squared plus 2x multiplied by 2x plus 2. And of course I can factor a 2 out, and this 2 and that 2 that I factor simplify. So if I want to write it more simplified, I can write it in this form. But the simplification is something else. The differentiation, this is today's lesson. Understandable?
Yes.
Okay. So let me skip number 3, because number 3 is easy. Let me go to number 4. Number 4, usually people make mistakes. So if it is sine to the power of 4, and then I have 3x squared plus 2. If you can do this yourself, it means you are on the safe side. You really understood the chain rule. Of course, you have to practice to be faster, but this is a very good thing. So you see here, can you tell me how many functions are involved here?
3.
It's more than 2, yes? So the first function is which function? The most inner function. This one acts first. And then which function comes later?
Sin x.
Sine of that. And then which comes after?
X
To the power of 4. Yes? So there are a combination of 3 functions. Okay, now if I want to solve it using this idea I told you, I want you to learn this example very good, so you can mark it so that you can come back to it later. So I need to take something to be u. Many people make the mistake and say that let us take this to be u. Okay? It is not wrong, but let us see what happens. Okay, let me go to a scratch paper. I am thinking for myself, for example. If I take this u, what happens? My function will be sine to the power 4 of u. If I take u to be 3x squared plus 2, this will give me this. But it is not good, because this, if I pretend u is x, then I will have sine x to power 4. Do I have sine x to power 4 in my table of derivatives? No. The only thing I have is sine x, not sine x to power 4. Is that understandable? So what I have in my memory or in my formula sheet is sine x only, not sine x to power 4. So taking this u at this stage is not good, because it gives rise to something which I don't know how to do. Okay, so if this choice is not good, this choice is not a good choice. So then what is another option that I have?
Take sine as the u.
Sine,
And the
yes, take the whole thing u in your head. Is this now a good choice? Yes, because now if I take the whole thing u, what do I have? I have u to power 4. But is it good enough? Yes, because if I pretend u is x, I can do it. It is in my table. So what is the derivative? Is 4u to power 3, but because of the chain rule, multiplied by u prime. So you see, this is a very simple but good example to understand if there are more than 2 functions involved, you have to give the priority to the correct one if you want to take it u. Is that clear?
Yes.
Okay. So now let us do it together. So what do you do? And then you will feel why it is called the chain rule. So if I take the derivative here, what happens? This, I have to take this one u in my head. You don't need to write them down in the exam, but you need to think along these lines. So this becomes 4u to power 3. So it becomes 4u, which is the whole package, to the power of 3, but multiplied by u prime. What is u prime? This is my u. So u prime means sine of 3x squared plus 2, totally prime. Yes? This is the first stage of the calculation. But hopefully you know that this is not done because there is a prime left. I have to continue. Okay. But this, forget about this part. Pretend that I have given you this from the beginning. Do you see this is another chain rule? Because this function acts first, and then sine acts on that function. Sine function comes after that. So copy and paste this part, because there's nothing I can do there. But when it comes to here, you have to do another chain rule. Then what can I take for u here? What?
3x squared plus.
Do you see that this was not good in the beginning, but this is now the only option here. So in my head, I take this to be u. Is it a good choice? Yes, because then I will have sine u. If I pretend u is x, I have it in my table. So there is, I have to multiply by another u prime. So help me to do that. So what do you think I will do? So this is sine of u prime. Sine of u, if I want to take it, if I pretend u is x, it becomes cosine in the table, u. The only thing you have to be careful is to multiply by u prime. So what should I do? I would write it as cosine of u, but multiplied by u prime. Now, do you feel this is a good name? It's like a chain. So when you think that this chain is finished, another loop is coming. Okay, so that's mean you have to do it until there is no prime left. Okay, so this means that you have to copy and paste a lot here. Multiply the derivative is 6x and you are done. If you want, you can multiply 6 by 4 and write it in the beginning. So 24x sine to the power of 3x squared plus 2, and then I have cosine 3x squared plus 2. So this is your answer. Yes? Is that understandable? Well, that's the chain rule. Okay, so let me do one more and then switch. Yesterday I didn't have time to complete this tangent and cotangent, but I have written the formulas there. If we have time, I will come back and complete them. Otherwise, you need to read it, study it yourself. It's very simple. Okay, can you help me now using the formula on the table? We want to do the next one. Square root of tangent square root of x. So we want to differentiate this function. So how many functions are involved here?
3.
3 again, yes? What is the first one? A squaring function. And then the second one, tangent function. And the third one again, squaring function. And that's very simple. So it shows that it is the chain rule. Okay, now tell me which one do you think at this stage is it a good idea to take this u? No, because if I start taking this u, I will have this situation. But the square root of tangent u is not in my table. What I have in my table is just tangent of x itself. So it shows me that taking this to be u at this stage is not appropriate. So, okay, if that's not a good choice, what is the good choice?
Tan of root x.
Yes, take everything to be u. Why this is good? Because in a scratch paper I will have a square root of u. I know the derivative is 1 over 2 square root of u if I pretend u is x, but now I have to multiply by an extra u prime. So I will take the derivative. It's 1 over 2 square root of u, but it is not finished. Multiplied by tangent square root of x, square root of x prime. Agree? Okay, but then this one is done. There is no prime there. There's one prime left here. Is this directly in my table? No, because of that square root of x. So it indicates that now I take another u here to make the problem solve. So I take this u. Then I will have tangent u. Tangent u. If I pretend u is x, I have it in my table. And then you see that there are three ways of writing this. 1 over cosine x squared, or 1 plus tan x squared, or secant squared. Secant is not mandatory in this course, but secant is an abbreviation for 1 over cosine. And we have also cosecant, which is an abbreviation of 1 over sine. That's it. 1 over cosine is called secant, 1 over sine is called cosecant. So I will use this, if you don't mind, because that's more compact. Okay, so if you see the table, if I pretend u is x, the derivative of tangent u is secant u squared. It is in my table. But the only thing I have to be careful is to multiply by u prime. Okay, so I copy and paste the first part. And instead of this, I write secant u squared, which is secant square root of u, square root of x squared. But the problem is still not finished because of that u prime. Yes? But this one is very simple. It is one of the formulas here. So I just put it there and we are done. So this becomes 1 over 2 square root of 10 square root of x secant square root of x squared times 1 over 2 square root of x. So that's your derivative. Okay, number 6. For number 6, what do you think is a good way? I don't want to do it. I want you to do it yourself. But how do you think about this problem if I want to differentiate it? First of all, don't jump into the chain rule because this is the sum rule. Yes, there is a sum. So if I want to differentiate, I have to differentiate this. I have to differentiate this and then add them up. Yes? But to differentiate this, I need the chain rule. The inner function is sine function, the outer function is tangent function. To differentiate this, I need the chain rule. So the inner function is x minus 1, then cotangent comes in, then a squaring function comes in. So they might also give you a question which is a combination of more than just the chain rule. So you need to know about those things as well, okay? Okay. So let me also skip question number 2. If we have time, we can come back. I mean, if you want to stay during the lunchtime, I will come back and solve them for you. But let us not count on it. So this is another type of question that they might design for the chain rule. Okay, consider the functions f and g such that the function g is completely given to you, but the function f, they have only told you that f prime at 7 is -6, nothing more. And they have told you that the function h is f after g, and they want you to determine h prime of 1. These are also another type of questions that they might ask you about the chain rule. Okay, so let me write the information here. You can also take your time to think, of course. Okay, so we know that g of x is equal to 2x squared plus 3. Am I right? No, plus 5. And then I know that f prime at 7 is -6. And they have told me that h is f after g, FOG. And then they are asking me to calculate h prime of 1. Yes, this is what we wanted. Okay, when you want to answer this question mark, h prime of 1, you want to calculate the derivative of a function at a number. First, you know you have to calculate h prime of x, and then replace x with 1 after you are done. So what I do, I would write h of x first. H is FOG, so h acting on x means FOG is acting on x, but FOG means g acts first, and then f acts on that. So if I want to take the derivative of h, because this is f after g, I have to use the chain rule. So you have to remember the formula for the chain rule. What was that? It was f prime, the derivative of the outer function, calculated at the inner function, multiplied by the derivative of the inner function. So that's the formula for the chain. Okay, but the question mark is h prime of 1. So what do you think I will do now? If I want to calculate h prime of 1, I have to replace x with 1. So if I replace x with 1, what happens? It becomes g prime of g of 1 multiplied by g prime of 1. Okay? So in order to answer this question mark, I have to answer two question marks. What is this number and what is this number? Because as soon as I find them, I multiply it. Okay, this one is very simple. Okay, so let me answer this question first. If I want to answer this question, what I'm supposed to do, I calculate the derivative of g, which is extremely simple. It becomes 4x, do you agree? But because I want g prime of 1, so I replace x with 1. So it becomes 4 times 1, which is 4. But how can I calculate this? If I want to calculate f prime of g of 1, first I need to know what that number is. Because f prime is supposed to act on g of 1. Do I know g of 1? It's very simple. So what is g of 1? So I copy and paste f prime and put these two pairs of brackets. And I ask myself, what is g of 1? It's very simple. So what's g of 1? G of 1, I replace x with 1 in g. So it becomes 2 times 1 to power 2 plus 5. As you said, it is 7. So this I write 7. But f prime of 7 was given in the problem. So the person who designed the question designed it in a way that we can continue. So what is f prime of 7 now? It is given in the problem -6. So what is the answer to the problem? Question mark is the product of these two numbers. So it is -24. Yes? So they can also design some questions a little bit more theoretical. So the next question is more theoretical, so let us also do that and then jump to the next part. Any questions regarding this? Understandable? Yes. So I mean that, for example, if f prime of, instead of 7, 1 was given, I couldn't continue. So the person who designed the question designed it in a way that it can be done. Okay? Okay, now let us go to the next one. It's also a good question. let f and g be everywhere differentiable functions such that f prime at 6 is 2, and for every real number x, this is the relation. F of 5x plus 1 plus g of 3x minus 2 is equal to 2x squared. We are supposed to determine g prime of 1. Okay? So we know that f and g are everywhere differentiable, and we have some relation. I know that f acting on 5x plus 1 plus g acting on 3x minus 2 is equal to 2x squared. I know that f prime of 6 is 2, and what is wanted from me? G prime of 1 is wanted. Okay, so you see, this is not one of those problems that we exactly know what to do. So how do you think about the problem? So what do you think would be a natural first step? Yes?
Differentiate both sides.
Why? Why do you think like that? That's very good. Because the information given to me is related to the derivative, and what is wanted from me is a derivative. And there is no derivative involved here. So the most natural thing to do is to differentiate. I mean, it might not work, but at least this is a good starting point. When you want to differentiate, be careful. This equality means I can write f of 5x plus 1. Let me write it in detail. If this equality holds, it means that the derivative of the left-hand side should also be equal to the derivative of the right-hand side. Is that right? The derivative of the right-hand side is extremely simple. It's 4x. But there is a sum here, and if I want to take the derivative of a sum, I have to do it piece by piece. Let me write every detail, okay? So 5x plus 1 derivative plus g of 3x minus 2 derivative. A common mistake is people put prime here. Be careful. I have the whole package. When I differentiate, I want to differentiate everything here. So don't put prime here. You have to put the prime on top. Everything prime, yes? But now hopefully you can see this is the chain rule. Yes? If I take this u in my head, this is f of u totally prime. So it becomes f prime of u, according to the chain rule, u is 5x plus 1. But the problem is not finished. I have to multiply by the derivative of u. So now you see how much it is important. If you mistakenly put prime up there, you will not get this factor, which is crucial. So you be careful about that. And then plus the derivative of the second one is, take this one u in your head again. So this becomes g prime of u, but it is not finished. What should I do? I have to multiply by 3x minus 2 prime. And on the right hand side I have 4x. I think the rest is very simple. So this derivative is what? The derivative of 5x plus 1 is just simply 5. If you don't mind, let me write it on the left side. And the derivative of this is 3, so let me write it on the left side. And it is equal to 4x. So this is the correct form of differentiating. If you didn't care about the chain rule, you will not have these factors involved, which are important. Okay, understandable or not?
Yeah.
Okay, now I want to continue. What the question is what is g prime of 1? So it means that I have to choose an appropriate value for x, which gives me some information about g prime of 1. And that is not hard. What x do you choose?
1.
If I choose x equals to 1, this gives me g prime of 1. That is good. Am I lucky? Yes, the person who designed the question designed it clearly. Because if I give 1, I have to give 1 everywhere. So this becomes g prime of 1. This is not under my control anymore. It becomes f prime of 6. And I don't have any problems with f prime of 6 because it was given in the problem. Okay, so if I want to finalize the problem, how can I do that? So we choose, because that relation is valid for every x according to the problem. So we choose x to 1. Then what happens? Then if I put it there, if I choose x1, it becomes 5f prime of 6 plus 3g prime of 1. On the right hand side, because I have chosen x to be 1, it becomes 4. Yes? But this number is given to me directly in the problem. It is 2. So it becomes 10 plus 3g prime of 1 is equal to 4. So this means that g prime of 1 is minus 2. Yes? So that's another type of problems they might ask if the chain rule is involved. Okay, so implicit differentiation, I will pause here and then after 5 minutes we come back. Thank you.